Alright, so we need another rule. That's why I broke the video where I did. And it's a real similar rule. So we just did a bunch of derivatives with e's. And basically to find the derivative of an e, you leave the e part unchanged and you multiply by the derivative of its exponent. The next derivative we're going to learn is when we have a number with an exponent that has an x in it. So a to the g of x. And its derivative is almost exactly the same. The only difference is we have to tack on a natural log of the base. So it's going to be the natural log of the base, just to leave myself room here, times the derivative of the exponent times the original function unchanged. So the rule's essentially identical. As a matter of fact, I could have written this rule with the ln. I could have said this was the ln of the base e times g prime of x times e to the g of x. But the ln of e is equal to 1, so you don't need that part. If I did on my calculator on second, whoops, not second, if I did ln, and then e is, I forget where e is at. Oh, e's on the divide key. Second divide, there's the ln of e, and it's equal to 1. So the reason the e rule doesn't have the ugly ln in it is because this piece is equal to 1. So these are really essentially identical rules. If it e to some power, then you just take the derivative of the exponent times that e to some power. If you have a number other than e to some power, then the rule's the same essentially. You take the derivative of the exponent, you multiply it by the original function unchanged, but you have to tack on times the natural log of the base. To show you how this rule comes about is way complicated, way more than you'd ever want to see, and it would take a gob of time, and it's just not hardly worth it. So here's 4 problems that use this rule. This rule we rarely use, but I need to expose you to it anyways. So f prime of x, I'm going to use the formula. The formula says first, if I have an x in the exponent, then I'm using one of these 2 rules. All the other rules, the chain rule, the power rule, the product rule, the quotient rule that we're using, those were when you didn't have an x in the exponent. You had a number in the exponent. We started using those rules. So I'm going to put down first the natural log of 7, because the base is 7. Then I'm going to multiply by the derivative of the exponent. The derivative of x is just 1. I guess I could use a parentheses. And then times the original function, which is 7 to the x. Don't need the times 1. So f prime of x is going to be the natural log of 7 times 7 to the x. Maybe I'll put that in the parentheses to separate them a little bit so it doesn't look like the 7 is part of the natural log. I think that's as well as I could write that answer, and that's it. (28), again, there's an x in the exponent. The base isn't an e, so I use this rule. So f prime of x, first thing I do is write the natural log of the base, which is the natural log of 7. Then I write the derivative of the exponent. The derivative of 2x is just 2. And then I write the original function unchanged. So that's the whole derivative. Putting everything in a separate parentheses maybe is a nice idea. This 2 probably could be written to the left of the natural log. That's kind of how it probably would be written. And if I write the 2 to the left of the natural log, it probably doesn't need to be in a parentheses. And it's never going to be bad when we get the natural log preceding a exponential function to put that exponential function, exponential meaning the letter has an x, the exponent has an x. That's probably the best way to write that answer, but I'd live with the top or the bottom. (30) is a product rule because there's multiplication. Product rule says I need to do the derivative of the first factor, so y prime is going to have the derivative of x squared times the 2 to the x unchanged, and then plus the derivative of 2 to the x times the x squared unchanged. So y prime, the derivative of x squared is 2x, so it's going to be 2x times 2 to the x power plus the derivative of this, I get the natural log of 2, times the derivative of the exponent. The derivative of x is just 1, so I'm not going to write it, times the original function 2 to the x. And then maybe times x squared. So that's the derivative. The derivative of that piece would have the natural log of the base, the derivative of the exponent, which is 1, and then the 2 to the x. And that piece doesn't change because I'm only taking the derivative of the x squared. Now I'll look for common factors. The 2 inside a natural log isn't a common factor with a 2. Those can't be factored out. But between that x squared and that x, there's a common factor of an x. And for these 2 to the x's, they're both a common factor. So I'm going to get x times 2 to the x. Actually write that times sign, although it's not necessary. And then a parentheses. From here I'm left with a 2. Over here I'm left with an ln of 2. That 2 to the x is gone. There were 2 x's. I took one of them out. I'm left with 1x. Probably couldn't write that much better. I kind of almost feel the urge to write the x to the left of that natural log, just because that's probably how it's written more commonly. I don't need the times sign between these two, but it's okay. It might be a nicer form of the answer, but this is completely okay. These don't come up that often that we have natural logs in our derivatives, so the rules for them aren't really as etched in stone. They're not done that often. So these last 3 derivatives with the ln's in them, they just won't come up that much. Last one with this rule, and then we'll move on to a new rule. Derivatives of logarithm functions. And they're not so bad. In fact, they're surprisingly nice. Cool. Alright, so you need to use a product rule again. So I'll write dy dx just so we don't forget about that notation. But I could have written y prime. It's going to equal first the derivative of x squared times the 2 to the x to the 4th minus 8, unchanged, and then plus the derivative of 2 to the x to the 4th minus 8 times x squared. Alright, let me do my derivatives. First one, I just have to do the derivative of x squared, which is 2x. So this derivative turns into a 2x, and then times 2 to the x to the 4th minus 8. And then plus, this derivative is ugly. First thing I get is a natural log of the base, so I'm going to get a natural log of 2. And then the derivative of the exponent, the derivative of x to the 4th is 4x cubed. The derivative of minus 8 is 0. And then I add the 2 to the x to the 4th minus 8 to it. That continues, that derivative has 3 pieces. The natural log of the base, the derivative of the exponent, and then the original function. And then this piece didn't change. It needs to stay there. I'm going to look for common factors. Between this 2 and that 4, I can factor out a 2. Between this x and any one of these x's, I can factor out an x. I'm going to take an x away from that one. And they both have a 2 to the x, 2x to the 4th minus 8, which I can factor out. What I'm left with, here I've factored out everything, so I'm left with a 1. It kind of surprises me. Here, from that 4, I factored out a 2, so it's going to be a 2. I'm going to write that first. I didn't do anything with the natural log of 2, so I'm going to leave it there. I factored that out entirely. Oh, I didn't do anything to that x cubed, so I need to leave it there. Factored that out entirely, it's gone. I took one of those 2 x's away, so I'm left with another x. Those 2 x's, I'm going to add their exponents and get an x to the 4th. So I'm going to say dy dx equals 2x times 2 to the x to the 4th minus 8 power times 1 plus 2 natural log of 2 times x to the 4th. And I might write the x to the fourth between the 2 and the natural log of 2, but that's probably getting really nitpicky. All right, one more derivative rule that we're going to learn, and it's a surprising rule, and it's actually an easy rule, but sometimes the simplifying is a little bit, you try to simplify when you can't, because it has to do with fractions. So I think this is the last rule. We might get one more. So if f of x equals the natural log of some g of x, some function, then f prime of x equals g prime of x over g of x. And this rule only applies when the function is positive, because logarithms, you get i's when they're negatives. In some texts, you'll see absolute values in the statement of the rule, and then it just makes it look more complicated than it needs to be. So to do the derivative of a natural log, it doesn't have a natural log in its answer, which is quite surprising. It's just the argument in the denominator and the derivative of the argument in the numerator. It's actually a really easy derivative to do. Sometimes students want to simplify when they can't, because simplifying fractions, if there's addition or subtraction in the numerator or the denominator, is very particular, and you can only reduce when you have exact copies in the numerator and the denominator if a fraction has an addition or subtraction in its numerator or denominator. So let me apply this rule. It's real easy to apply. So if you have a function that has a natural log, its derivative in the denominator just has the argument. The thing that's in the parentheses goes in the denominator. So in the denominator is going to be the argument 2x. In the numerator, it's going to be the derivative of the argument. The derivative of 2x is just 2. And now there isn't any adding or subtracting in either the numerator or the denominator, so I can cancel the 2's. If there was an addition in either the numerator or the denominator, I probably couldn't cancel like this. So I'm going to cancel. Those will turn into 1's. And for my answer, I can't write a fraction without a numerator, so I'm going to write 1 over x. Again, technically, I probably should have written this problem as the natural log of the absolute value of 2x to make that only be positive, but we're just assume that this only works when for values of x that make the original function defined, but we won't worry. It's not important. Oh, there is. I did sneak the other one in here. Oh. All right, one more rule, and it's essentially the same rule. Just like we had a rule for e and a, we get a rule for ln's and we get a rule for logs. ln is just log base e. The rule is going to be just the same. F prime of x, it's going to have the same f prime of x. I wrote that over there far to give myself some room to write something else. It's the same g of x in the denominator, g prime of x in the numerator. And just like when we did the difference between an e and an a, this is a difference between an e and an a, because ln is log base e, and the difference between an e and an n, you need the ln of a, and in this case it's going to go in the denominator. So I'm going to use that rule here in a second. So for logarithms that aren't base e or aren't ln's, I have to do exactly the same thing, but I tack on another fraction. And 35 and 36 are exactly that. They're log base 10. In a logarithm, if a base isn't written, it's assumed to be base 10. So when I go to do the derivative, I take the original function 2x in the denominator of a fraction. The derivative of that, the derivative of 2x is just 2. That goes in the numerator of the fraction. That's not enough because the base is 10. And I have to go 1 over the natural log of 10. Now I'm going to cancel. The 2's are going to cancel again because there isn't any addition or subtraction. There's only multiplication in the denominator, so I could cancel those. This is going to give me y prime equals 1 over the natural log of 10 times x. And that's probably written fine enough. Those come up really, really infrequently. Derivatives of logs that aren't base e, that aren't ln's, won't come up almost at all. As a matter of fact, I had to lick that rule up because I use it so infrequently. Alright, so to do the ln of x squared minus 5x, I'm going to go dy dx equals, I'm going to make a fraction, and in the denominator I put the argument x squared minus 5x. In the numerator I take the derivative of that. The derivative of x squared is 2x. The derivative of minus 5x is minus 5. That's a perfectly acceptable answer. You can't cancel anything. The only thing I could do to make this maybe a little bit better is factor out an x from the denominator. But a 2x minus 5, because of the minus sign between the 2x and the minus 5, can only cancel with a 2x minus 5. And it can't cancel with a single x, it can't cancel with a single minus 5. When you have addition or subtraction between a letter and a number in a division problem, you can only cancel exact copies. Since there isn't another 2x minus 5 anywhere in the denominator, there's nothing that can be canceled. That's the whole answer, with or without the common factor factoring. 40 is the same problem, but it has a log in it. So I'm going to go y prime, make my denominator. Any logarithm, you do its derivative by taking the argument and putting it in the denominator. The derivative of the argument goes in the numerator. Because it's not base e, I have to tack on 1 over the natural log of the base. And then the best I can do is common factor. The numerator, 1 times anything is itself, so the numerator is going to be 2x minus 5. The denominator, I can say it's the natural log of 4, and then pull out that common factor of x. But nothing else is going to reduce. You can't cancel a 2x minus 5 with an x minus 5. I can't cancel an x with the x and the 2x minus 5. So that's the whole thing. 42 is an ln, so f prime of x is going to equal to, in the denominator, the argument x plus 5 cubed. In the numerator, I need to do the derivative of that x plus 5 cubed, and I'm going to shortcut the chain rule. So I'm going to write the exponent 3, leave myself some room, lower the exponent by 1 to 2, and now I'm going to multiply by the derivative of the inside of the parentheses. The derivative of x is 1, the derivative of 5 is 0, so the derivative of the inside of the parentheses is just 1. X plus 5's can cancel with each other. So this x plus 5 squared and that x plus 5 cubed, those are identical factors, they can cancel. I'm going to cancel out both of these and leave myself one of those 3 left. And my x plus 5's are going to be gone from the numerator. What I'm uncancelled in the numerator is a 3 times 1, which is a 3. And in the denominator, I'm left with x plus 5 to the first power. Probably would be better to write that without the parentheses or without the exponent. So both of these are the best answers for 42. Probably this one's better because it doesn't have a parentheses or an exponent that aren't necessary. (44) is the same problem. So if I'm doing 44, the only difference between 42 and 44, they're exactly the same, except you have a log base 7 as opposed to an ln. The only thing that's going to be different, my answer is just going to have 1 over the natural log of 7 times that answer. But I'll do this out. But because they're the same problem, the derivative is going to look the same, other than it's going to have this extra tack on. So let me do it like I didn't know that. These were the same problems. So for my derivative, f prime of x, I leave myself some room, make a fraction. In the denominator of the fraction, I write the argument x plus 5 cubed. In the numerator, I shortcut chain rule. So I'm going to go 3, leave myself some space, and then x plus 5 squared, and then multiply by the derivative of x plus 5, which is 1. Because it wasn't an ln, I have to tack on 1 over the natural log of the base, which is 1 over the natural log of 7. Canceling works the same way. Both of those cancel, takes me down to one of those. But in this problem, I'm probably going to wind up leaving the parentheses in my answer. In the numerator, I'm going to multiply 1 times 3 times 1, which is 3. And in the denominator, I have the L natural log of 7 times x plus 5. And that's the best I can do with that. I'm not going to clear this parentheses or drop this parentheses like I did in the last problem. All right. Good. I think we're done with the logs and all into ln's now. Yeah, ln's all the way through to the end here. So, to do the derivative of a natural log, I go g prime of t equals the denominator, square root of 3t plus 1. And I need the derivative of that in the numerator. Well, that's not written so nicely for doing derivatives. So this is going to be 3t plus 1 to the 1/2 power. Makes it easier for me to do the derivative. It's a chain rule. I'm going to shortcut chain rule. First I'm going to write 1/2, leave myself some room, and then I'm going to go 3t plus 1, and then for the exponent I'm going to go 1/2 minus 2/2, and I'm going to get a negative 1/2. And then in that hole that I left, I'm going to write the derivative of the contents of the parentheses. The derivative of 1 is 0, the derivative of 3t is 3. I'm going to multiply these, and I'm going to move this down to the denominator. So I'm going to get g prime of t equals 3/2 over 3t plus 1 to the 1/2 for that one, and 3t plus 1 to the 1/2 for that one. And then I'm going to add the exponents. So I'm going to get g prime of t equals 3/2 over 3t plus 1 to the 2/2. And that's just 3t plus 1, because we get an exponent of 1. So I get g prime of t equals 3/2 over 3t plus 1. I probably don't need the parentheses anymore. What to say? You got to be wearing out, because I'm wearing out, and we still got a chunk of ways to go. And 1 minute, I think I could explain this. So this problem right here, this is really g prime of t equals 3/2 divided by 3t plus 1. If I wrote that answer without the fraction bar, I could make it a division. So this would be g prime of t equals 3/2 times 1 over 3t plus 1. Then I can multiply the 3 and the 1 and get g prime of t equals 3, and multiply these and get 2 times 3t plus 1. That's the best ultimate answer for problem 46. It's a nice way to simplify. So when you have these 3-layered fractions, you can take the third layer and move it into the denominator or the numerator. It'll work like that every time. And I was just going to say you could do that, but this is why you can do that. And then I might wind up doing that more often than not if I get a 3-leveled fraction again. Just kind of tuck it together and make it a 2-leveled fraction. So give 45 a crack. My video is going to pause, and I'll continue on in a second here. 48, product rule. So y prime is going to equal to, first I have to do the derivative of x squared. So it's going to be the derivative of x squared times the natural log of 9x plus the derivative of the natural log of 9x times x squared. Oh, this is going to be lovely. Y prime equals derivative of x squared is 2x, and then times the natural log of 9x, plus the derivative of the natural log of 9x. You put 9x in the denominator, and then the derivative of 9x, which is 9 in the numerator, times x squared. Alright, so this is going to give me y prime equals 2x natural log of 9x. These 9's cancel, so you get plus 1 over x times x squared. And here you could actually cancel out one of the x's. You can cancel out the x from the denominator with one of those two x's, and you'll be left with an x. So after I cancel, I have y prime equals 2x natural log of 9x plus 1 times x, which is just x. And now I'm going to factor out an x. So the best answer, y prime, is going to be x times 2 times the natural log of 9x plus 1. This is the beginning of the grunge of calculus, just manipulating your answers to get them in the best form. That requires a lot of really fine algebra skills that maybe you'd never had, or you had but you lost. So as I'm going through the videos, I'm trying to do enough explanation that hopefully you could reproduce it for your version of the problem. I always try to give two problems that have the same level of difficulty. If I have two problems on a sheet and one of them is harder than the other, I always try to make mine the harder one. I think 47 is a little bit easier than 48. At least it looks easier. Alright, another product rule. So f prime of t of y is going to be the derivative of 3y minus 4 times the natural log of 7y plus the derivative of the natural log of 7y times 3y minus 4. This one's going to be ugly. I'm probably not going to simplify this near as much as the last one. So, first derivative. The derivative of that minus 4 is 0. Derivative of 3y is 3. So the first piece comes out to 3 times the natural log of 7y plus the next piece, the derivative of the natural log of 7y. You have a 7y in the denominator. The derivative of 7y, which is 7, goes in the numerator, times 3y minus 4. The 7's are going to cancel. I get f prime of y equals 3 times the natural log of 7y plus, if I consider this over 1 and this 1, I'd go 1 times 3y minus 4 is 3y minus 4. Y times 1 is y. I'm not going to go any further because there's no common factors now. I can't reduce that fraction. You can't cancel those y's because there's a subtraction in that numerator. There isn't a common factor. There's definitely probably things I can do. I can make this have a denominator of y and add things together, but this kind of problem won't come up that frequently. That's far enough to go for that. When there's common factors, I always factor them out though. And if there's canceling to do, I always do the canceling. There's no common factor and there's no canceling. I feel done here. Ugh. Really. Alright, so this next derivative is going to be a little bit ugly as well. Alright, so product rule. F prime of x, f prime of y is going to equal the derivative of 3y minus 4 times the natural log of 7y minus 6 plus the derivative of the natural log of 7y minus 6 times 3y minus 4. The derivative of 3y minus 4 is just 3 because the derivative of 3y is 3, the derivative of minus 4 is 0. So the first piece comes out to 3 times the natural log of 7y minus 6. Second piece, I do the derivative of the natural log part. And the 3y minus 4 I'm going to write over 1 just because it's going to help me. So for the derivative of the natural log part, the 7y minus 6 goes in the denominator. The derivative of 7y minus 6, which is just 7, goes in the numerator. And this is going to give me f prime of y equals 3 times the natural log of 7y minus 6 plus 7 times 3y minus 4 over 7y minus 6 times 1, which is 7y minus 6. I'm not going to go any further than that. There's no common factors. 3 and a 7 don't have a common factor. ln's aren't going to have a common factor with something that doesn't have an ln. If I wanted to, I could distribute the 7 through that parentheses and make that a 21y minus 28, but it's not really necessary. Those are grungy. I can't imagine those coming on the test, those last two problems that don't have any common factors. They're not that common, but I just want you to get used to just different versions of junk. 54 is division, so it's a quotient rule. Quotient rule says I need to do the denominator. So f prime of x is going to be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So f prime of x is going to equal the denominator e to the x times the derivative of the numerator, the derivative of the natural log of x, minus the numerator, natural log of x, times the derivative of the denominator, e to the x, all over the denominator squared. I wonder if yours is actually harder than mine. I might do yours here in a second. So f prime of x is going to equal to e to the x, the derivative of natural log of x. I put the x in the denominator. The derivative of x goes in the numerator. The derivative of x is 1. And then minus natural log of x times the derivative of e to the x. Its exponent has a derivative of 1, and then time the original function, all over e to the x times e to the x, which is e to the x squared. Common factor of an e to the x here is pulling at me. I'm going to pull out that common factor. So I'm going to get f prime of x equals e to the x times 1 over x minus the natural log of x over e to the x times e to the x. Can definitely cancel out one of those e to the x's. And I get, I don't know if I want to go further. You can definitely go further. Since we're not doing anything with the derivative, I'm not going to go further. Let's stop there. I could get the numerator more simplified, but I don't really care to at this point. That's definitely far enough. So I pulled out common factors, divided what I could. That's far enough. Let me try 53 with you. So for 53, I start off f prime of x equals the denominator, natural log of x, times the derivative of the numerator, minus the numerator times the derivative of the denominator, all over the denominator squared. So f prime of x equals natural log of x. E to the x is its own derivative because the derivative of the exponent is 1, so I get an e to the x there. Minus e to the x times the derivative of the natural log of x. I get an x in the denominator, its derivative in the numerator, all over the ln of x times the ln of x, which is the ln of x squared. I'm going to factor out the e to the x, and nothing's going to cancel. So your answer is going to be almost like mine, just slightly different. So f prime of x is equal to e to the x times the natural log of x minus 1 over x over the natural log of x quantity squared. Nothing cancels. The only other thing I could do is combine those two terms in the parentheses by getting a common denominator. I didn't do that for my 54. Well, you won't have to do it for your 53. Ugga, 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 ugga. So just a few more problems on this phase of the video, and then I'll do a part 3. 3 more problems. They look enough the same that I'm only going to do mine. So quotient rule. Y prime, or dy dx, equals the denominator, the natural log of t, times the derivative of the numerator, minus the numerator, 2t minus 5, I snuck it in a parentheses, times the derivative of the denominator, all over the denominator squared. I didn't put this extra parentheses, but I could have. Alright, so in the numerator, the derivative of 2t minus t is just 2. I'm going to write that before the natural log. So for my first part of my numerator, I'm going to write 2 times the natural log of t, which doesn't cancel with that natural log of t, minus 2t minus 5 times the derivative of the ln. In the denominator, I get a t. In the numerator, I get the derivative of that, which is 1. I'm going to consider this a 1, and then I'm going to go all over the natural log of t squared. So I'm going to get dy dx equals 2 natural log of t minus 2t minus 5 over t over the natural log of t squared. That's not the nicest answer. These can be combined by getting a common denominator of t, but it's not going to look infinitely better, and there aren't any common factors I could factor out. There's nothing I could cancel. I'm going to leave my answer there, even though I could go further. In these last few problems, when I've left terms in the numerator, one with a fraction, one without a fraction, there's the possibility of making the second term have a fraction and combining them together to simplify more. That's just not a step I think is important in a Math 212 class. In a Math 220 or 230 class, maybe I take the time to do that. But for now, since I'm just finding the derivative, I'm not going to go any further. Ugh. These problems didn't look that disgusting when I wrote them, but they are. 58, k prime, it's a product rule, so it's going to be the derivative of e to the 3x times the natural log of 5 minus 4x plus the derivative of the natural log of 5 minus 4x times e to the 3x. So that's the product rule. First times derivative of the second times the first. Derivative of e to the 3x, I take the derivative of the exponent, which is 3. Its derivative is 3e to the 3x. I keep this natural log part around. The derivative of the natural log part, you have a 5 minus 4x in the denominator, the derivative of that, which is minus 4 in the numerator, and then times e to the 3x. I'm going to factor out an e to the 3x because there's certainly a common factor, and that's probably all I'm going to do. So I'm going to get k prime of x equals e to the 3x times 3 times the natural log of 5 minus 4x plus a negative 4. I'm going to write a minus 4 over 5 minus 4x. You can't cancel something with a natural log with something that's not part of a natural log. And again, just like the last three problems, I had inside a parentheses something that had a fraction and something without a fraction. It's definitely possible to make those two terms into one fraction, but it's not necessary. We'll just stop right there. Pulling out common factors is going to be enough. Last one for this part of the video. All right. Product rule. Y prime equals the derivative of e to the x squared minus 3x plus 1 times the natural log of x plus the derivative of the natural log of x times e to the x squared minus 3x plus 1. All right, first derivative. To do the derivative of an e, you take the derivative of the exponent. The derivative of that exponent is 2x minus 3. You multiply it by the original function. And then I leave the natural log of x. I don't do anything with that. Next piece, the derivative of a natural log of x. You get the x in the denominator, the derivative of x in the numerator, and I'm leaving that e part alone. Common factor of the e that I'm going to factor out. I'm going to get y prime equals e to the x squared minus 3x plus 1 times 2x minus 3 ln of x plus 1 over x. I'm going to leave my answer there. It's kind of what I did for my answer in 58. I could definitely clear this parentheses. Sometimes it looks odd to see parentheses inside of parentheses. So if I took the time to do that, it probably would be nice. That would give me 2x ln of x minus 3 ln of x. That probably is a little bit nicer. And just like the last three problems, I left a fraction inside my parentheses and didn't make these all have the same denominator. Again, since I'm not doing anything but finding a derivative, I'm not going to take that extra pain and make those together into a single fraction because it's just not that important. All right, I'm pausing this video. The last part should be nice and short.